Hi people, welcome back to the next little lesson there. I know the first one was quite a long one, but I explained concepts there. I'm looking at the document which is on Blackboard there, which is under, I think, your exercises 1. Okay, so I did number 1 and I did another one, extra one, and I'm going to look at number 6 here. Okay, number 6 looks like that there. Okay, sorry, number 6 looks like this. Yes, right. A force of 120 Newton pulls eastward on the pin. Right, so let's draw it. Yeah, you need to understand how the drawing works. Okay, but if you get things in the wrong way or the wrong direction, and of course the way structure. Sorry people, I've got neighbors who was banging on the roof here. They're working on. Just started just shortly after I finished the other video. Sorry about that. Alright, let's see. Let me draw it out. Right. A force of 120 Newton pulls eastward on the pin. So let's draw it out. So eastward, it's acting like so. Oh, didn't want it, did I? I want a straight line. Yeah. Here we go. That's 120 Newton. A second force of 160 Newton acts on the pin. This one is pulling on the pin, so the pin is sitting over here. Okay. A second force of that acts on the pin, so that means it's pushing on it. Acts on the pin in the direction of 60 degrees south of east. Right. Let's see. South of east. So I'm going to draw in my southwest lines. So that is my north-south line. That's north, and that is my west line there. Okay, let me just get out of there. So that's my north line, that is my south line, of course that's my east line, it's acting on there, and that's my west line. Then it says we have a force acting, a second force of that amount acts on the pin in a direction of 60 degrees south of east. Right, so let me just see. I'll just give me a second here. Right, and the second one second force acts on the pin in the direction of 6 degrees south of east. So let's see. Right, so something like so. (160 Newton), and it says actually on the pin in the direction of 6 degrees south of east. So that angle inside there is 60 degrees. 60 degrees south from east. Calculate the magnitude and direction. Right. Which way do we expect the result to act? We expect the result to act somewhere in this direction over there. Okay. So what's the first thing we do? We resolve this force that is not either horizontal into its components. That one we don't resolve because it's horizontal. Right, let's see. So that's going to be like so. And that's going to be like so. That's 60, so that's 60 over there. Yeah? So this one here is 160 cos 60. 160 cos 60. This one is 160 times the sine of that same angle. Right, what's the next thing I do? I sum verticals and sum horizontals. Right, let's do this. Right. So I say the sum, it doesn't matter where I start, I'm going to say the sum of the verticals is equal to. Right, how many verticals do we have acting? We've only got that one, and it's minus. Sorry, that shouldn't be naught, eh? Not yet. That's the next lesson. So it's minus 160 sine 60. 160 sine 60 degrees. And you pick up the calculator and you work at the answer, and you don't continue until you got it right. 160 sine 60. It is 138.56, and that's minus 138.56 newtons. What does the minus sign means? It means the net vertical forces are acting that way. Then are some horizontals. Doesn't matter where you start, horizontal first, doesn't matter. How many horizontal do I have acting? 1, 2. So it's plus 120 plus. Why is it plus? Because they're both acting horizontally to the right. 160 cross 16 is equal to, pick up a calculator, you work at the answer and you check your answer against mine, and only when it's correct you proceed watching the video. And I get exactly 200 newtons. The answer is positive. It means the net force is acting that way there. Okay, then I draw my little rectangle. So I'm going to have a force acting like so, and I'm going to force acting like so. So if I complete my rectangle, okay, that force there is 200, and that force is 138.56. So my resultant is going to go from the tail of those two there. So my resultant is going to be sitting somewhere over there. And I am going to work at that angle there. Or I can work that one. I'm going to choose to use that one there. Remember, that's the angle, that's the angle, that's the angle between that component there and the resultant. It is not the direction. Right. So therefore, resultant, the resultant is equal to, using Pythagoras theorem, the resultant is equal to 200 squared plus 138.56 squared, 138.56 squared. Do my calculation, you do it too, and you check it, and you proceed only when it's correct. Right, people, I got 243.31. 243.31 newtons. What's my answer? Yippee! Looking good. Okay. 240. I'm working to two places after the decimal, so that is excellent, perfect. 243.31 newtons, and of course that's the magnitude of the resultant. I'm going to work at the angle theta, which is not the direction, and theta is equal to the arctangent of 138.56 over 200, and that is equal to, oops, let's see, I'm going to do the calculation. It is, I'm going to check, do the calculation yourself and see that you get the same answer as me before you proceed. And the angle theta there, I get as 34.71 degrees. Is that the direction of the resultant? No, it is not the direction of the resultant. It is just the angle between the 200 Newton component and the resultant. So therefore, direction, I'm going to write it the way I normally do it. So if that's that angle there, maybe I should just change this color here. Let me make this green color. Okay, so that's my north line, that's my south line, that's my west line, and that's my east line. Okay, so if that's 34.71, the direction, using my conventional notation, is the distance all the way around to there. So it's 360 minus that one, 360 minus 34.71, and it is equal to 325.29, 325.29 degrees. Or, do you see the word or? It's either that or the other one. Or you can say it is 34.71 degrees south of east. South of east. Yippee! Looking good. Okay. Or you can say it is, if we choose to use that angle there, it will be 90 minus that one. So it's 90 minus 34.71. You can say either or. It's 52.29 degrees east. Yeah? East of south. It's south, so it's east of south. Job done. Okay, finish. Okay. So we resolve the components, some vertical, some horizontals. We drew out a little rectangle. We've used Pythagoras theorem to find the resultant. We found it to be 243.31 newtons. We worked at the angle and not the direction. Some of you just never get this. You need to get it right in your brain. Okay. So the angle between that component and that there is 34.71. So therefore the direction using my convention is from there all the way around to there. It's 360 minus that, which is 325.29 degrees. Or if you want to use that angle inside there, you can say it's 34.71 degrees south of east, as the author got it there. So it's perfect. Or if you want to use that one there, it will be 90 minus that one there. It will be 52.29 degrees east of south. The direction is either that, or either that, or either that. If they don't look like this, you'll get the directions wrong. Okay, people, that's just, maybe I must try and do another one quickly. Okay, I'll dream up one, and then we'll do a number 4, and then you're on your own for that first exercise. Right, people, there's the next one. The question is to determine the magnitude and direction of the equilibrant. Ne? The equilibrant. But before we can do that, we first need to determine the resultant. And how do we determine the equilibrant? The equilibrant is equal to, in magnitude, to the resultant, but opposite in direction. Okay? So because the forces are acting this way, we expect the resultant to be going somewhere in this direction over here. Okay? Right. What's the first thing we do? We resolve all forces into components. Notice both of these are not vertical or horizontal, so we have to resolve both of them. Right, let's do this. Okay, so so that one's looking like that, and that one's looking like this, and it is, that's 51, so that's going to be 47 cos 51, 47 cos 51, and that's going to be 47 sine 51 over there. Okay, and I'm going to make that on a bluey one. Didn't do it. Right, 62. So that's 62 there. So that's going to be 38 cos 62, 38 cos 62. That's going to be 38 sine of that same angle. 38 sine 62. Right, let's do this. Right, some vertical, some horizontals. Doesn't matter which way. Anyone first? I normally take the verticals first. You'll see later on in the course why I normally choose the verticals one first. I'll mention it there. So the sum of the vertical forces is equal to, how many vertical do we have acting? We got this one and that one, and they both minus 47 sine 51 minus 38 cos 62. Pick up the calculator, you work it out, and you check my answer, and you proceed until you get the same answer that I have. And I get minus 54.37. Right, minus 54.37 newtons. And the net vertical force is negative. That means it's gonna go down. And I'm summing horizontals. That will be minus plus. I always try to write the plus first, because often when people start with the minus, they forget to leave it, they forget to write in the minus sign, and they get it wrong. Doesn't matter the order, just take all of them. 38 sine 62 minus 47 cos 51. Right, check the calculation. And proceed only when you have the same as I do. Right, and I get plus 3.97. 3.97. newtons, and it's plus. That means the resultant or the net force going horizontally is going that way. Okay, so that means if I draw my little sketch here, I've got a force going this way. It's nasty. Maybe let me throw it over there. Let me throw it here. So it is so if I complete my rectangle, it's like so. And the resultant, we expect it to go this way, like we said. No? We expect the resultant to go somewhere in that direction over there. So it's looking good. Okay. Right. So that there is 3.97. And that there is 54.37. 54.37 Newton. And I'm going to choose to work at that angle this time around. Just to confuse you even more. I'm only joking. Okay. So, R, okay, will be the Pythagoras theorem. R will be equal to, R is equal to 54.37 squared plus 3.97 all squared is equal to, work out the answer and check yours against mine. Don't assume mine is correct. I get 54.51 Newton. And if you leave out the Newton here, I will take a mark because it's Christmas. Okay, so that's the magnitude of the resultant. And the direction, sorry, my apologies, theta is the angle, it's not the direction. And the angle there is arctangent of 3.97 over 54.37. 54.37, and that's equal to, and I'm getting 4.18. Right. Are we done? No, we're not done. Okay, that's just the angle. And secondly, the question wanted the direction, the result. Sorry, the question wanted the magnitude and the direction of the equilibrant. Right. Let me just move this quickly, like so, one side there, like so. Right. So we can say therefore, equilibrant is equal to, remember it's the same size, to 1 Newton, and a direction is equal to, now remember, the equilibrant goes along the same line of action as the resultant, but opposite in direction. So if I just finish this off, if I just draw that like so, and I draw that like so, okay, that's my, and if I extend this like so, okay, that will be my equilibrant there. So of course that angle there is equal to that angle there. Okay, so of course E is equal to this, but the direction is equal to all of that around there. So if the angle inside there is 4.18, then the direction from my notation will be 90 plus 4.8, so it will be 94.18 degrees. Or, I'm not going to state it now, or you can say it is 4.18 degrees. Let me just finish off this here. That's my, I'm writing, that's my north line, that's my south line, that's my east line, my west line. So, or you can say that the direction for the equilibrant is 4.18 degrees west of north. Did you get it? Maybe I should state it there. Or it is 4.18 degrees west of north. And of course, if I take that away from 90, so 90 minus 4.18, it is 85.82. You can say, or it is 85.82 degrees north of west. Okay, so people, that's the answer to that one there. So the equilibrant is equal to the resultant. Okay, and the angle inside is 4.18. You can say the direction is either 94.18 degrees because it's the direction that goes all the way around to there, or you can say it's 4.18 degrees west of north, or if you want to use that angle inside there, it is 85.82 degrees north of west. Okay, right people, that's all I'm going to work through for this type of problem. On Blackboard, if I just flick the Blackboard just ever so quickly there, exercise 1 and vectors and resultants, it is, yep, oh, it is all of that. Okay, it is all of that there. There's this one was the one I was looking at there. So I've done number 1, and I've done another one, and then I've done number 6, and then I've done the 4th one now. And then if you go to Blackboard, you'll see there that you can actually rotate this, by the way, if you didn't know yet. I think you can rotate it another time. There we go. You can actually rotate it. You can scroll down. Oh no, I didn't want to rotate it, did I? There we go. There we go. There we go. There we go. Okay. So, and there's, so exercise 1 is all of those over there. Okay. Yes. So have a go with that. I want to do another 1 or 2 types out of this here, and then you must do the rest. Okay. And if I go to the next exercise there, exercise 2, vectors and resultant, looks like this. After I've done 1 or 2 examples, you'll be able to finish all of that. And I always give you the answers. I always give you the answers. Okay? From this point, I always give you the answers. And if I go to exercise 3, which is exercise 3, vectors and resultants, there's another one there, and they get a little harder. So I might do another 1 or 2 to work through, just to start you off and help you with those ones over there. Okay, so I'm going to work through I'll do another 1 or 2 videos maybe, which will help you to be able to work through exercise 2 and exercise 3, and then you need to complete and work through all of those. And if I just scroll it up again, let me just rotate and rotate again, and another time. There's the answers. They're all there. There's the answers there. There's the size of the forces. Okay. There's the answers. Okay. There's the answers. I give you the answers so you work toward the answers, and you don't stop working until you get the answers. If you're really struggling, send me an email to my andersr@cpt email address. Ask me a question. I'll get you back, I'm sure, within the day. You can continue from there. Okay, so how much you want to learn, how much you want to take in, depends on yourself. Okay people, all the best, and soon I will post up another 2 videos to help you with exercises 2 and exercises 3. Okay, and I shall see you in the next video.